Hello again, everybody. Welcome back to episode 014, part 3. If you haven't seen parts 1 or 2, this might not make a lot of sense to you, so I encourage you to explore those if you haven't already. In this episode, in this part of this episode, I'm going to explore the dispatch portion of this code. The general idea here is that some old web browsers have JavaScript functions attachEvent and detachEvent, which are invoked upon HTML elements to attach event listeners or event handlers for different types of events for those HTML elements. And then modern web browsers have addEventListener and removeEventListener counterparts to attachEvent and detachEvent. And in this episode, I've attempted to establish addClassEventListener and removeClassEventListener counterparts, but the difference for these two new functions, these two new counterparts, is that instead of being invoked upon HTML elements, they will accept a new argument, a first argument that specifies a class name for an HTML class, which can appear as an attribute for HTML elements. But I still want to handle events in an event handling paradigm consistent with that of modern web browsers, just to take a look at the elements involved and their classes and respond or react or operate based on those classes. All right, so down here, what have I got? I've covered addClassEventListener already in part 2. So I'm going to move on to ClassEventListener. This property of this code object is a function which takes an event as an argument. This function is what actually gets registered for the document element for each different event type. And what is it going to do here? It's got two variables, derived_event and stop. The first thing it checks is if the event's got a property called cancel bubble, and if it's true, this is going to return. It's not going to take any further action. All of the class-based event handling will be aborted, so to speak. Then, if assuming we get past that, there is no such true cancel bubble property of the event, I'll establish stop to be an object that has two properties, now as false and soon as false. And what's the point of this stop object here? This is to support a few different ways to stop event handling propagation. And there are two functions commonly found in modern web browsers. One is called stop propagation, and one is called stop immediate propagation, and those correspond to this now and soon. Stop immediate is associated with now, and stop is associated with soon. Stop propagation with soon, stop immediate propagation with now. The next thing to do is to create a derived event based on the current event and tying in that stop object. So I call code.deriveFromEvent, and I pass those two arguments and take the result and I put it in derived event. Then I'm going to use setTimeout to schedule this dispatch class event listeners function for the next JavaScript event loop tick, so to speak. And where does that come from? That's right here. This function is a closure so that it can enclose the derived event that was just established and the stop object that was just established. And that function is going to be what gets scheduled during event handling. And why am I scheduling it? Well, I want all of the real or native event handling to fully complete before I begin this class-based event handling phases, the batch of phases for class-based event handling. So that's why I'm using setTimeout there. And what about this derived from event? That's right here. It takes event and stop as arguments. It has a few variables, derived_event, derived_event_prototype. Has is a shortcut for has own property in the object.prototype object. And prop and prop underscore val. The first thing I do is I make a function called derived underscore event underscore constructor, and it does nothing. That function does nothing. Then I also establish a derived event prototype object, which is empty. And then I set that derived event prototype empty object as the prototype property for that function, derived event constructor, the function. And then I'm going to use the new keyword to create a new instance of the derived event constructor and store the result as derived event. And I'll explain why in just a moment, why I'm using these two different kinds of object, both derived event and derived event prototype. So I'll iterate over the property names that are found in the original event. That was part of the native event handling. And for each property, I'm going to set prop val equal to that property of the original event. And I'll carry that around by default. Then I'm going to check a few special cases for overrides. So I'm just switching on the value true here to find out if any of these cases is true. I'm going to check if the property name is stop immediate propagation. What does this mean? If the original event has a property called stop immediate propagation, I'm going to override that. Prop val was the original function that was found as a property in the event, but instead I'm going to override it with code.makeStopImmediatePropagation, and I'll pass it the stop object. What is this going to do? We'll see in a little while, but it's going to return a special function, an individual function for the derived event, and I'll store that into prop val, and I'll break out of the switch for that case. Same sort of thing for stop propagation. I'll call makeStopPropagation and pass it stop to make a new function that gets stored into this prop val. Another possibility is that this particular property of the original event is a function. If it's a function, getters and setters in modern JavaScript are more complicated than in older JavaScript, and it might be the case that a function property for an event, if you try to copy that into another object, such as this derived event, which is intended to be something like a copy of the original event, if you try to invoke those functions as properties of another object, you might get an error. It's not a valid thing to do with certain getters and setters, for example. So instead, what I'm going to do is I'm going to invoke code.wrap. I'll pass the original event, and I'll pass the function that was discovered as a property of that original event. And this is going to return a function that just binds together the original event with the property value and return that as a new function for this prop val variable. And that'll ensure that if somebody calls the same name of property on the derived event, it's actually not going to use a this of the derived event. It'll invoke the wrapped function with a this feature of the original event in order to avoid errors. And it doesn't have to be functions in particular. Getters and setters can also interfere with just regular property names as well. So then what's next here? Because an event can have inherited properties and properties that are direct properties of the event, I'm going to try to mimic both of those cases as best I can. I want to go and explore the original event for its inherited properties, and I'm going to make those inherited properties of the derived event, and I'm going to take the direct properties and make those direct properties of the derived event. So that's what I check here. If the original event has the property name as a direct property, then I'll set that as a direct property on the derived event from the prop val. Otherwise, it's an inherited property. I'm going to try to mimic that and set the prop val as a property on the prototype object so that it appears as an inherited property for the derived event. And then some fix-ups. It's possible that there was no stop immediate propagation property, for example, in an older web browser. So if it's the case that stop immediate propagation for the derived event at this point here is not a function, then I'll do the same thing as explored earlier. I'll use code.makeStopImmediatePropagation with stop passed to it, and that'll return a function. I'll set that to be stop immediate propagation for derived event. Same thing for stop propagation. And I'll also check if there's a bubbles property for derived event. If it's exactly equivalent to undefined, then I'm going to establish a bubbles property for the derived event to true by default. And if there is no target property of the derived event, I'm going to assume an older web browser which uses the src element property of events, source element property, and I'll assign that into the target property of the derived event. So this supports old web browsers, some old web browsers. And then I return the derived event. Okay, what's next here? Dispatch. This is an exciting function here. So it takes an event. It's going to actually be the derived event, though, because of what happened earlier during the class event listener. And it's also going to take the stop object as well. It has variables bottom, class underscore name, current, element, element underscore classes, entries, I, middle, prefix, target, top, and type. Wow, there's a bunch. And what am I going to do here? Middle is going to be established as an object that has element set to the event target. That's the element that would be applicable for the target phase of event handling. Entries is going to be an empty array property. And next will be set to null. I'm setting up a linked list here. I'm trying to schedule things. So we've got the 4 phases: none, capture, target, and bubbling. And I'm going to try to schedule them in the right order. So I'm going to build a linked list where the target phase is represented by this middle object with the event target as its element. And then I'm going to build nodes in the linked list before that middle node to represent the earlier capture phase, and after the middle node to represent the later bubble phase. But to begin with, I set bottom to be that same middle element, top to be that same middle element, and for convenience, I'll set the type variable to be the event.type. So here's the iteration here through the HTML elements. I'll start with element being assigned to be the event.target element, and as long as it's not null, as long as it's a truthy value here, so to speak, then the next iteration it'll be assigned to element.elementParent, or parent element, excuse me. So this will climb up from the target element up through the containing elements all the way until it reaches a state where the parent element is null, and that'll be the end of the iterations. What do I do inside here? Element classes get set to the class name of the element, and this corresponds to the HTML class attribute for an HTML element, and it's expected to be a string of space-separated class names. If it's an empty string, I'll skip over this element. Nothing to do here. It has no classes, therefore there are no event handlers to be associated with the event that's being dispatched. So I'll skip to the next element. Otherwise, we get past that. I'll split the element classes by the space, and the result will be an array, and I'll reassign element classes to be that array. And then I will iterate over the elements of that array, each class name that appears. So I set the class name to be the element of the current iteration, and then I build up this prefix variable. I take the class name with a space after it, with the event type after that, and with another space. And this is going to resemble the properties that we see for the code.entries object, but with a little missing piece at the end. And that missing piece comes right here. So for the registrations for the capture phase for a given class, I'm going to check the code.entries object for that prefix with capture as the phase appended to it. And if there is such a registration, a group of registrations, then I will fetch them and get the corresponding entries, but I'm going to copy that array. I'm not going to manipulate or work with or expect the original entries array for that registration to be consistent. Instead, I'm going to make a copy, and that way I can expect that copy to remain consistent throughout all of this event handling, no matter what happens out of band from this event handling. And so I'll fetch those entries, and then here's a little bit of a encumbrance, but it's a special case here. It's going to be invoked for each iteration, but that's not so bad. I'll take a look if the element that's currently being processed is the event target element. Then I'm going to know that I'm in the middle part of the linked list. I'm working with that. So I'm just going to discard that empty array that was established earlier and replace it with the entries that were discovered. Otherwise, it's time to build a node in the linked list for the capture phase, and it should become ahead of the middle element. So I'll take whatever the previous top is, I'll make it the next property of a new object, and the element property will be the currently iterating element, and the entries will be set to the entries that were just fetched, and that whole object will become the new top object. So as we iterate through the elements, any that match the right conditions, they have classes that have entries, it'll keep building up entries before the middle element for the capture phase and hopefully get them in the right order. By the time we get to the parent, it will be the topmost element, for example. Then I'll check if the event has a bubbles property that is false. If it's false, there's no need to schedule any of the bubbling registrations. So I'll just continue to the next element. Otherwise, the event is assumed to bubble, and I will check that the same sort of check here. I'll add bubble to the prefix, check that as a property for code.entries, and if that exists, I'll fetch the entries and make a copy of them. And down here, I'll check if it's in the target phase. If it is, I should add those entries to the target phase. So I'll take the middle entries that might already exist. They might be an empty array from the beginning of this function, or they might be the entries that were fetched for the capturing. And whatever they are, I'll concatenate the entries that have just been fetched for bubble registrations, and then restore that as the entries property of middle. Otherwise, we're not working with the event target, and I'll do a comparable building for the top as for the bottom. I'll build an object called bottom.next. I'll set a new object to be the next property of bottom. It'll have the element as the current element, the entries as the current entries as the entries property, and its next, because it's at the bottom of a singly linked list, will be null. And then for the existing bottom object, whatever it might be, whether middle or something that's been built in a previous iteration, I will set the new bottom to be this new object. And that'll sort of tack it on to the end of the linked list. Then, after building up the scheduling, the linked list for scheduling, I'll iterate through the schedule. I'll start with current equal to top for the topmost element of the capture phase. And as long as the current variable is not equal to null, and if the stop object's soon property is false, then the body of this loop will be executed. And for the next iteration, current will be set to current.next, and that's just this next property of each of these linked list nodes. Inside the body, I'll set the element to be the current linked list node's element, and the entries likewise. Then for each one of the entries, I'll iterate over those as long as the stop.now property is also false. So there are two kinds of ways to break out of this loop that are not just strictly related to the iteration itself, but whether we should stop soon or stop now. And I'll explain that in just a moment here. Inside that inner loop, entry will be set to a particular entry within the entries array. And if it's been removed, if its property removed is set to true, we'll skip this entry. Now this could happen if during event handling, remove class event listener was called with a combination that resulted in a deregistration of an entry. And the way to communicate that to this loop here is to use this removed property. So that'll allow it to be skipped. And another way to abort the processing here is if the registration and the listener had a signal property for the entry. If it has a property aborted that is true, then that's another sign that we should abort event handling for this particular registration. And so what I do is I invoke remove class event listener, and I'll pass it entry.className, entry.type, entry.listener, and entry itself. And that's because entry is comparable enough to the options object that it can be used as an options object. So I'm passing entry itself as the options for remove class event listener, and it will result in the right kind of matching. It's got the class name and the type and listener as well. After it's been removed, then I'll continue on to the next entry. If we get past that, I'll check if the element is equal to the event.target, if the HTML element is the event target element. If so, no matter how it was registered, whether it was registered as a capture phase or bubble phase, I'm going to set the event phase to 2 for the target phase to indicate that. Otherwise, I will set event phase to be the entry's event phase, whatever it was registered with. So this is some of the complication of event handling here. From the event perspective, there are the 4 phases, and from the registration and deregistration perspective, those functions, there are 2 phases, capture and bubble. And down here, I'll check if event cancel bubble is true and we're in the bubbling phase, it's time to stop what we're doing. We don't want to do any bubbling stuff. So I'll set stop.now to true, stop.soon to true, and I'll break out of this loop. At the next iteration of this inner loop, it'll find that stop.now is true, it'll break out of that loop, and it'll also find that stop.soon is true, and it will break out of that outer loop. So that's what cancel bubble will cause in the bubbling phase. Otherwise, we get past that, and I'll check if entry.handler is truthy. It can either be null for the case of a registration where a handle event object was not being used, or it'll be non-null for the case where the programmer passed in a handle event object as the listener. So for either of those cases, I set up target to be either entry.handler for the handle event object case, or the target element, the HTML element, otherwise. And then I'll also ensure that when the event handler is invoked, it sees this property, current target of the derived event, is equal to the element, no matter what. That should always be the HTML element. Then I'll use a try, and I'll invoke the func property of entry. I'll call that with the target as the this, either the HTML element or the handle event object, and with the derived event as an argument. And whether or not that throws an error, that'll get executed, and we'll continue on with iterations here because I try to catch the errors. Whatever was thrown will be caught in this caught variable, and I'll schedule code.eventListener deferred throw. I'll pass it along some useful troubleshooting pieces here. What was thrown as caught, the entry, the element, and the event. All of that will get passed this. This event listener deferred throw will be shown in just a moment. It's going to return a function, and so that function will be scheduled for the next tick with set timeout, as opposed to interrupting the event handling flow. And then we get past all of that, and I'll check if the entry was registered as a one-time event listener through this once property. If that's true, we've executed it one time. Now it's time to remove it, and so I'll invoke remove class event listener once again and get rid of that entry. After all of the iterations through the schedule, I'll set current target to be null for the event and event phase to be 0 for the event, because somebody could take a reference to this event from an event handler and keep it around and examine it later, and it's good for the sake of consistency to set this to null and this to 0 so that if somebody later on examines that event, they'll see it's not being processed. Okay, and here's event listener deferred throw. All it does is establish a closure that will throw the event that had been caught earlier, and it will enclose that with rethrow, and it will return that function for that set timeout. And I think I've already discussed main in part 2. Here's make stop immediate propagation. All it does is have a closure where it takes the stop object that was passed in and it accesses it, and it sets its now property to true and its soon property to true, and it returns that closure for stop immediate propagation. Make stop propagation is about the same, but it doesn't stop all propagation right away. It only stops the propagation for the next HTML element to be processed in event handling. And so it sets soon to true there. And I think I've covered maybe callable and process common arguments already. And is that it? I think that might be it. I think that's probably, wrap was explored a little bit earlier. That takes a function that was a property of an original event and ensures that that function gets applied with the original event as it's this, but passes along whichever arguments are passed to the wrapper, and then it returns that wrapper. Okay, and that concludes HTML class-based event handling in JavaScript. Thanks so much for your patience in exploring this code, and I'll hope that you'll find it useful. Take care, have a pleasant day, goodbye.